Hello everyone. This video walks through completing Packet Tracer Assignment 3.4.2.4, Configuring GRE. This Packet Tracer assignment is a part of the Cisco R&S Connecting Networks version 6 curriculum. Now, in this particular lab and in this chapter, in chapter 3 of the Connecting Networks curriculum, we're looking at how do we configure kind of like a VPN tunnel from one site to another that are not close to each other at all. So you'll notice in our lab assignment here in our topology, we've got maybe a site over here, the RA router, okay, and it's LAN. Then we got it connected to a wide area network, but if you notice, this IP address is totally different than this network, okay? And there's just a lot of stuff in between here. We really don't need to know what's in between here, just like in real world situations. We don't always know what routers and switches, layer 3, layer 2, all the stuff that goes on between us and the destination that our internet service providers or tier one companies control. We don't have any control over that. But we will configure a VPN and we'll see how it kind of bypasses all of that and creates like a little mini tunnel from site to site, from RA to RB. So there's a couple of different things we have to do to sort out this tunnel. All right. So first, it has you configure tunnel 0 on interface RA. So let's go to RA. Whoops, wrong button. Enable config T, and we're going to do interface tunnel 0. Kind of like we did with our virtual interfaces if you're doing like a loopback or VLAN interface or anything like that. So you still do interface and then you just name the tunnel, okay? Now, we're going to name the tunnel the same thing on both ends. No need to change the name so we can kind of know which one matches up with the other router to make it easier. Now, here we're going to put our IP address. This is our virtual IP address for the tunnel. It's 10.10.10.1. Now, again, you'll notice here our physical interface, S000, what it's connected to on both routers are not in the same network. 64.103.211.0/30 only's got 2 available addresses. That's this one on RA, S000, and whatever it's connected to over here. Over here, you got 209.165.122.0. The /30 means you got 2 usable IP addresses, one on RB's S000, and then whatever it's connected to. This 10.10.10.2 and 10.10.10.1 are on the same network, though, each end of the tunnel. So you see we kind of got a virtual interface IP address, and then we got our physical interface IP address, which are not on the same. These are the same network, okay? So we set that. And then the next thing we're going to do is put the tunnel source, okay? So tunnel source S000. It's basically saying on RA, what is my, you kind of like bonding the tunnel interface, whatever interface you're going to be receiving traffic on RA with that IP address, okay? Next, we'll do tunnel destination. Okay, and we're actually going to put the physical interface of S000 on RB, okay, not the 10.10.10.2. This is the physical IP address, and we're going to do it going the other direction as well. So this one's 209.165.122, and then you want to consult your addressing table up here. So 122.2, okay. Okay, so that sets the tunnel destination. So we got the tunnel source is going to be that. When I send it out, I'm sending it to that physical IP address on S000 on RB. All right. Then we're going to set our tunnel mode. Okay, you see next in our directions, we're going to set our tunnel mode as GRE IP. Let me get back there. All right, tunnel mode GRE IP. Now they tell you to type in no shut, but you notice right here it already came up. So either way, no harm, no foul there. As long as it's up, that is what we're looking for. Okay. So again, tunnel name or number, we put it 0. The virtual IP address needs to be on the same network as the other end. What interface are you going to be receiving traffic on? Kind of bonding these two together. What is your physical interface destination on your other router, and then set the mode. Okay, so let's try it on RB. They don't give you all these directions on RB, so maybe a little bit trickier, but we're going to get through it. So again, we'll go to configuration mode and we'll do interface tunnel 0. Now we're going to set our virtual IP address, which is 10.10.10.2 this time. So /30 subnet mask, or 252. Okay. Now we're going to set our tunnel source. The tunnel source happens to be S00 as well. That does not reference anything on RA though. That's solely on RB, because you see here S000 is the one on RB that I'm going to be receiving traffic in. Now the tunnel destination again does not need to be the virtual interface on RA. It needs to be the physical S00 interface that is receiving in on RA. So that's going to be 64.103.211 and .2. Okay. So oops. Okay. So 211.2. 64.103.211.2. All right. Now we'll set our tunnel mode. Tunnel mode Gre Ip. We got to make sure they're the same on both ends. And again, they tell you to type no shut, but it already came up for me. Okay. So we did that, but just in the reverse order on RB. So we got the tunnel established. Okay. But we have to make sure they can talk to each other. Now remember back all the way to like your second Cisco class, we actually covered static routing. So in that, we need to put a static route to be able to reach each of these virtual interfaces. And that's what they have you do next, okay? So when I want to reach 192.168.1.0, instead of sending it to the physical address, I'm going to send it to the virtual address. Anytime RB wants to reach that one up there, anytime RA wants to reach 192.168.2.0, I'm going to send it to this virtual interface. Remember, no matter what routing protocols you've got running, static routing will most likely override that because of that administrative distance. The administrative distance is basically shows like what route is most desirable when you do a show IP route. The lower the administrative distance, the better. Remember, directly plugged into it is a 0. Can't get any better than that. A static route that you set is a 1, where all of your dynamic routing protocols like EIGRP is 90, OSPF is 110, RIP is 120. So it's a lot higher. So even if you've got static routing, or sorry, dynamic routing going on here, the static route will actually override that. And we want it to because we want it to use this tunnel instead of using everything else. Okay, and you'll see why in a minute. So on RA, all right, we're going to do an IP route. Okay, and then 192.168.2.0. My subnet mask for that is 255.255.255.0. So it's RA reaching this LAN on RB. How do I do that? Now, remember there's two methods. You got the recursive method, which is like the next hop IP address. So when it leaves RA, what IP address do I want to send it to? Okay, that would be 10.10.10.2. Okay, we have to use the recursive method with this. Oops, sorry. You needed to be back one interface to enter that in. So you want to, again, when you enter that in, you want to use the recursive method or the next hop IP because you got to put the interface, the virtual interface you want to send it to. If you just say send it out of S000, which is also possible when you're doing a static route, that wouldn't quite work here. Okay, so now we're going to go to RB and we're going to try to reach 192.168.1.0, which is the LAN interface off of RA 255.255.255.0, and we're going to send it to the virtual interface of RA, which is 10.10.10.1. Oops, sorry, again, need to be back one. All right, so now we have connectivity from end to end on our routers. Now, this is interesting, okay? So we're going to send a ping from there to there. It'll say failed. We refire it. It says successful, right? That's great. Now, that's always good, but let's see how this actually works. They have you do a tracer command. So let's go to PCA, let's go to command prompt. Instead of just doing a simple ping, I'm going to do tracert, T-R-A-C-E-R-T, and then I'm going to type in the IP address of PCB. So PCB is, it says PCC in these directions, but that's not right. It's PCB. Okay, so 192.168.2.2. This is going to leave PCA, go to SA, go to RA, and then we're going to see what happens. Now, a normal tracer, if we would have did this before, would have showed all the different bouncing around that it did in this cloud from router to router to router. I mean, it might be 20 of them, who knows? And then it would have came out on the other side. Now, let's see what happens here, though. You'll notice it says it leaves my network, right? And then it goes to 10.10.10.2, then it goes here. Okay, so it's basically saying I leave PCA, I get to RA, and then I just automatically just magically get to RB, and then I get to PCB. What happened to all this stuff in between here in the internet cloud? That's because we got our VPN. So it's kind of like making a direct tunnel through all of it to where it doesn't really see anything else. So it's got that direct tunnel using GRE configured right now. Okay, and if you did it the opposite way, you would see the same thing. So if we went up here to PCB, tracer 192.168.1.1, I think that's the IP address. Oh, no, 1.2, sorry. All right, so you see the same thing. It says it leaves PCB, goes to RB, and then it goes directly to RA. That's the virtual interface on RA, and then it gets delivered to PCA. So instead of it being like 20 different hops, that's what these numbers are, you know, like 1, 2, 3, it's changing routers or networks, then it only is 3 because it, again, has that direct tunnel in between there. All right, so that gives 100 out of 100. I hope that it helps explain why and what we're doing in the operation of tunneling, creating kind of like a VPN using GRE.